The impossible room. There is a room hidden inside a secured research facility. No windows, no markings, no identifying features. Just four walls, a ceiling, a floor, and a network of cameras watching every angle, every second of every day. The room was designed to be perfectly ordinary. Its dimensions were measured down to the millimeter. The temperature was controlled, the air pressure stabilized. Every variable was logged, analyzed, and archived. For weeks, nothing unusual happened. When someone stood inside the room, it behaved exactly as expected. Straight lines remained straight. Corners held their 90-degree angles. Shadows followed the laws of light and geometry. Reality remained quiet, predictable, and stable. But the room was not being tested for what happened when someone was inside. It was being tested for what happened when no one was there. The first strange readings appeared during a routine maintenance window when the chamber was completely empty for several minutes. The cameras continued recording, their red indicator lights glowing in the dark. No alarms triggered, no systems failed. Yet when the footage was reviewed later, something was wrong. The perspective did not match the measurements. One corner appeared slightly farther away than the room's physical dimensions allowed. A shadow bent at an angle that no light source could produce. The walls seemed to lean inward. Not enough to be obvious, but enough to feel incorrect. At first, engineers blamed compression errors, lens distortion, digital artifacts, but the distortions repeated the next time the room was left empty, and the time after that, and every time after that. The moment a human stepped back into the chamber, the image stabilized instantly. The walls returned to perfect alignment. The shadows corrected themselves. The impossible angles vanished as if they had never existed. Nothing in the physical space appeared damaged or altered. Only the recordings showed the change. It was as though the room behaved differently when it knew no one was watching it directly. Not recorded, not monitored, not stored on a server. Watched. The cameras could see the room, but the room did not seem to care about cameras. It only responded to human presence, to awareness itself. As long as someone stood inside, the room remained obedient to reality, silent, stable, predictable. But when the room was truly alone, when no eyes were inside it, when no mind was directly observing it, something else began to emerge. Angles that should not exist, distances that quietly stretched beyond their limits, geometry that slowly forgot how to behave, a space no longer anchored by observation, a room that changed when you left. Because in this place, one rule became disturbingly clear: observation keeps it still. The experiment begins. The room was never meant to be special. It wasn't designed to test the limits of reality or challenge the nature of perception. There were no classified objectives, no warning labels, no sealed vaults hidden behind biometric locks. On paper, it was simply a controlled environment chamber, a neutral space used to study how physical structures behave under long-term isolation and constant monitoring. The facility itself sat far from public attention, surrounded by industrial buildings and anonymous concrete corridors that all looked the same. Inside, everything followed strict procedure. Every door required authorization. Every movement was logged. Every piece of data flowed into quiet servers humming behind glass walls. The chamber was built to be boring by design. Its dimensions were modest, a rectangular room large enough for two people to stand comfortably without touching the walls. The surfaces were smooth composite panels, painted matte white to eliminate reflections and glare. The ceiling held recessed lighting, calibrated to maintain constant brightness without flicker. The floor was reinforced with vibration-dampening layers to prevent micro-movements from influencing measurements. Nothing about the room invited imagination. A network of high-resolution cameras was installed in each corner and along the ceiling seams. They overlapped their fields of view intentionally, eliminating blind spots and depth ambiguity. Infrared sensors tracked temperature distribution. Laser measurement tools mapped spatial consistency down to fractions of a millimeter. Microphones captured ambient sound pressure, even though the room was expected to remain silent. The project proposal was simple. Observe how enclosed spaces slowly deform due to environmental stress, material fatigue, and time. Concrete expands and contracts. Metals warp microscopically. Even synthetic materials slowly drift away from their original tolerances. Most changes are too small for human perception but accumulate over months or years. By placing the chamber under constant surveillance, researchers hope to build predictive models for long-term structural stability in sealed environments, submarines, space habitats, underground facilities. It was routine research, quiet, unremarkable. The initial calibration phase lasted 2 weeks. During this period, engineers verified every sensor repeatedly. The room was occupied for short intervals, while technicians adjusted lighting, checked alignment markers, recalibrated the lasers, and ran diagnostic sweeps on the cameras. Every measurement matched the blueprint precisely. Angles stayed true, distances remained fixed, no unexpected thermal gradients appeared. The data streams were clean and predictable. When the room was empty during short testing windows, nothing unusual appeared either. The cameras recorded perfectly symmetrical geometry. The algorithms flagged no anomalies. The space behaved exactly as a space should behave. If anything, the room was boring. By the 3rd week, the experiment officially transitioned into passive observation mode. No one needed to be inside the chamber anymore, except for scheduled maintenance. The systems would record continuously, feeding the data into automated analysis software that searched for gradual trends over time. Most of the research team barely thought about the room at all. It became just another data source in a building full of them. The first irregularity did not trigger alarms. It appeared as a minor deviation in spatial mapping, less than a millimeter of apparent shift along one wall. The system flagged it automatically, but the value fell within acceptable error margins. Sensor noise, calibration drift, a rounding artifact in the reconstruction algorithm. A technician briefly reviewed the log and dismissed it without comment. Over the next few days, similar micro-deviations appeared intermittently, always small, always subtle, always disappearing on the next scan cycle. No consistent pattern emerged. The fluctuations did not correlate with temperature changes, vibration data, or power cycles. Still, no one was concerned. Complex systems generate imperfect data. That is expected. The entire purpose of long-term monitoring is to separate meaningful signals from statistical noise. Then came the maintenance window. Once every 2 weeks, the chamber required a full systems check. The power to non-essential equipment was temporarily rerouted. Engineers entered the room to inspect panel seams, clean camera lenses, and confirm sensor alignment. The procedure usually took less than 30 minutes. On that day, the process began normally. 2 engineers entered the chamber, ran their checklist, confirmed that all readings matched baseline values, and exited the room. The door sealed behind them with a soft mechanical hiss. The corridor lights dimmed as the facility shifted into low-activity mode. For the first time since continuous monitoring began, the room remained completely empty for an extended period without anyone actively watching the live feed. The cameras continued recording automatically. No one noticed anything unusual in real time. The anomaly was discovered hours later during a routine data aggregation review. A junior analyst scanning through compressed visualization summaries paused on a frame that felt off. The image showed the empty room from one of the corner cameras, but the proportions seemed subtly wrong. The far wall looked slightly deeper than expected. The angle where 2 walls met appeared just a fraction too wide. At first glance, it was easy to dismiss as perspective distortion, but curiosity lingered. The analyst pulled up the raw footage, switching between camera angles and overlaying measurement grids. The discrepancy remained consistent across multiple viewpoints. The lasers reported distances that did not match the apparent visual geometry. It wasn't dramatic. It wasn't obvious. But it was there, a quiet inconsistency. When the analyst cross-referenced the timestamp, something stood out. The anomaly occurred during the exact window when the room was completely empty and unattended. No personnel inside, no live observers monitoring the feed, only automated systems recording in the background. The next morning, engineers entered the chamber again for unrelated checks. Everything inside appeared normal. Manual measurements matched the original blueprints precisely. The walls were straight. The corners were perfect. The distances aligned flawlessly with baseline values. The inconsistency existed only in the recorded data from the empty period. A follow-up review was scheduled. The team initially suspected a synchronization issue between the laser mapping system and the camera timestamp alignment. Software engineers ran diagnostics. Firmware logs were checked. No errors appeared. The equipment behaved normally. Still, the anomaly remained unexplained. Out of professional caution more than concern, the team decided to increase sampling frequency during future empty intervals. Additional redundancy checks were added. More detailed logs were enabled. The experiment continued. No one called it strange yet. No one imagined it was the beginning of something that would quietly challenge their understanding of space itself. At that moment, the room was still just a room. A simple chamber built for boring measurements, waiting. The first anomaly. The decision to increase monitoring sensitivity was not dramatic. There were no emergency meetings, no urgent warnings sent through the facility. The anomaly discovered during the maintenance window was still classified as a low-priority irregularity, an unexplained fluctuation, but not yet a threat or a breakthrough. Additional sampling protocols were activated quietly. Laser scans increased in frequency. Camera feeds were archived in higher resolution. Time synchronization between sensors was tightened to eliminate micro-latency mismatches. Automated pattern detection thresholds were lowered, allowing the system to flag even the smallest geometric deviations. If the distortion was a technical problem, the data would reveal it. If it was something else, the data would reveal that too. For the next several days, nothing unusual appeared. The room remained stable during occupied periods. Engineers entered periodically for unrelated system checks, and each time the chamber behaved exactly as expected. Physical measurements aligned perfectly with the digital models. The monitoring dashboards displayed clean, predictable graphs. The earlier anomaly began to feel like a false alarm. Then, late one evening, the room was left empty again. The facility was operating in reduced staffing mode. Most personnel had already left for the night, leaving only essential systems running and a skeleton crew monitoring infrastructure health. No one was actively observing the chamber's live feed. The cameras continued recording silently. At 02:17 a.m., the first clear deviation appeared. One of the corner cameras captured a subtle shift in perspective. The far wall seemed to pull backward by a few centimeters, not abruptly, but gradually, frame by frame, as if the space itself were stretching. The laser mapping system recorded a corresponding increase in apparent depth, yet the physical boundaries of the room remained unchanged according to fixed reference anchors embedded in the structure. Two independent measurement systems were now disagreeing with the known physical constraints. The automated software flagged the event immediately. A notification appeared on the overnight monitoring dashboard, but no one noticed it in real time. The alert was logged, time-stamped, and stored for morning review. Over the next 11 minutes, the distortion continued to evolve. The angle between two adjacent walls widened beyond 90 degrees by a measurable margin. Shadows began to behave inconsistently, bending away from the direction of the ceiling lights. The convergence lines used by the vision algorithms no longer intersected at valid vanishing points. The geometry was becoming internally inconsistent, yet nothing moved physically. No panels flexed, no sounds were detected. Vibration sensors remained flat. Temperature and pressure stayed within normal operating ranges. The room was changing without changing. At 02:29 a.m., the distortion stabilized. The room appeared frozen in its altered state, holding an impossible configuration that should not have been able to exist within Euclidean space. Then, at 02:31 a.m., a maintenance technician entered the chamber to retrieve a forgotten tool from earlier in the evening. The moment the door opened and human presence returned to the room, the geometry snapped back into perfect alignment. The walls straightened, the angles corrected, the shadows normalized. The shift occurred in less than a second. The technician noticed nothing unusual. The room appeared completely normal. Only the recorded data captured the transition. By morning, the alert logs had accumulated enough anomalies to demand attention. A review meeting was called. Engineers gathered around the visualization displays, replaying the footage in synchronized slow motion. The distortion was unmistakable. The stretching perspective, the widening angles, the impossible shadow behavior, all of it unfolded smoothly and consistently across multiple independent sensors. This was no longer sensor noise. Multiple camera feeds confirmed the same spatial deformation from different viewpoints. Laser distance measurements showed matching discrepancies. Even depth reconstruction algorithms, operating on separate hardware, produced identical warped models. Three separate systems agreed on something that should not have been physically possible. The room appeared to violate its own dimensions. The first hypothesis was still technical: calibration drift, firmware bugs, clock synchronization errors, or subtle thermal expansion effects not captured by standard sensors. A comprehensive diagnostic sweep was launched immediately. Every cable was tested, every lens was inspected, every sensor was recalibrated. No faults were found. The hardware behaved perfectly. Software logs showed no corruption, no buffer overflows, no dropped frames, no timing errors. The algorithms performed exactly as designed, yet the data remained. The distortion had occurred only during the period when the room was completely empty and unwatched by any human observer. This correlation could no longer be ignored. To test whether the anomaly could be reproduced intentionally, the team designed a simple controlled experiment. They cleared the chamber completely. No personnel remained inside. All non-essential lights in the surrounding corridor were dimmed. The live camera feeds remained active, but no one watched them directly. The displays were turned away, and automated recording continued in the background. The room was left alone. For the first several minutes, nothing happened. Then the geometry began to drift again, not identically to the previous event, but following a similar pattern: depth expansion, angular deviation, shadow inconsistency. The deformation progressed slowly, as if the room were cautiously testing the limits of its own structure. At the 20-minute mark, the distortion exceeded the previous anomaly by nearly 30%. When a researcher re-entered the chamber, the room corrected itself instantly. The experiment was repeated several times over the following days. Each time, the pattern held. When humans were inside the room, the space remained stable. When the room was empty but actively watched on live monitors, minor deviations sometimes appeared, but they remained limited and inconsistent. When the room was empty and completely unwatched by any human observer, the distortions became stronger, more coherent, and more pronounced. It was not enough for cameras to see the room. It had to be seen by a mind. This realization unsettled the team more than the distortion itself. The implication was subtle but profound. Observation, conscious awareness, seemed to influence the physical behavior of the space. The chamber behaved as if it resisted being unobserved. Some researchers cautiously referenced observer effects in quantum mechanics, though no one claimed a direct connection. The scales involved were far too large. A macroscopic room should not respond to observation in this way, and yet the data suggested otherwise. Late one evening, while reviewing footage alone, one engineer noticed something even more disturbing. During the longest unobserved interval, several frames displayed geometry that could not be reconstructed into a coherent three-dimensional model at all. The depth maps overlapped in ways that violated spatial continuity. Certain points appeared to exist in two positions simultaneously. The reconstruction software flagged these frames as mathematically unsolvable. The room was not merely deforming, it was briefly becoming something that could not exist within conventional space. Those frames were rare, lasting only fractions of a second, but they were real, preserved in the raw data stream. No compression artifacts, no sensor errors, no processing glitches, just impossible geometry. The team documented everything meticulously. Internal reports grew longer. Language became more cautious, more precise. The anomaly was no longer referred to as a fluctuation or deviation. It became known simply as the First Anomaly. Not because it was the largest, but because it was the first undeniable proof that the room was not behaving like a normal space. Something was happening when no one was watching, something the room was not supposed to be able to do, and the experiment was only just beginning. Repeated tests after the first anomaly was confirmed, the experiment could no longer continue as routine research. What had started as passive monitoring became an active investigation. The room was no longer just a chamber of neutral measurements. It had become a question no one yet knew how to ask properly. The research team expanded. Additional physicists, imaging specialists, data analysts, and systems engineers were quietly brought into the project. Access restrictions increased. Internal documentation was compartmentalized. Every test protocol now required multi-level approval, not because anyone believed the room was dangerous, at least not yet, but because the integrity of the data had become critically important. If this phenomenon was real, it had to be isolated, reproduced, and measured with absolute precision. The first priority was control. The team designed a series of structured trials meant to isolate exactly what variables influenced the room's behavior: occupancy time, observation method, lighting conditions, camera activity, human presence, human attention. Each variable was tested independently. In the earliest trials, a simple pattern was confirmed quickly. When a person stood inside the chamber, the room remained geometrically stable without exception. They tried different individuals, different heights, different body masses, different positions within the room. Standing still, walking slowly, sitting on a temporary stool. No matter who entered, the space obeyed normal geometry. The room behaved like a room. Next, the team tested partial occupancy. One person would stand in the doorway without fully entering. Another would observe through a narrow window in the adjacent corridor. Motion sensors confirmed the precise location of each observer relative to the chamber boundary. When any part of a human body crossed into the room's interior volume, the distortions stopped completely. Even a single hand extending past the threshold was enough to stabilize the geometry. But observing from outside the room produced inconsistent results. Sometimes minor distortions appeared, sometimes none at all. The effect was weaker, less predictable. The boundary seemed to matter. It was not just observation, it was presence within the space itself. The next variable was attention. Could the room distinguish between being seen casually and being actively observed? To test this, researchers left the room empty while live camera feeds were displayed in a control room. At first, multiple staff members watched the monitors carefully. No significant distortion occurred. Then, without changing the video feeds, the observers deliberately shifted their attention away, reading unrelated material, turning their chairs slightly, or closing their eyes briefly while the screens remained visible in their peripheral vision. Within minutes, subtle geometric drift began to appear. When their attention returned fully to the monitors, the drift slowed or stabilized, though it did not always reverse immediately. This suggested something deeply unsettling. It was not enough for photons to hit a retina. Attention itself seemed to matter. The room behaved differently when it was consciously perceived. Skeptical team members argued that subconscious bias or delayed reaction times could be influencing the interpretation of the data. So the team added biometric tracking. Eye movement monitors verified exactly where observers were looking. EEG headbands measured general cognitive engagement levels, not for medical analysis, but to correlate attention patterns with room behavior. The correlation strengthened. When focused human attention was absent, even if the room was technically visible on a screen, the distortions increased in magnitude and speed. The next phase tested duration. How long could the room remain unobserved before significant distortion occurred? The team conducted timed absence experiments. 5 minutes unobserved, minimal drift. 10 minutes, measurable angular deviation. 20 minutes, visible perspective distortion across multiple sensors. 30 minutes, geometry entering unstable ranges. At 40 minutes unobserved, the deformation became severe enough that the reconstruction software began generating ambiguous models with overlapping depth layers. At no point did physical sensors detect structural stress or material movement. The room was behaving like a changing image, not a changing object. Another variable was lighting. They experimented with full illumination, low light, near darkness, infrared-only visibility, and complete optical isolation while maintaining non-visual sensors. The distortions occurred regardless of lighting conditions. Darkness did not stop the effect. Visibility was not the mechanism. Observation was. The team also tested whether artificial intelligence could substitute for human observation. Automated vision systems were trained to analyze the room continuously. Advanced pattern recognition algorithms flagged geometry deviations in real time. The systems watched the room far more consistently than any human could, and yet the distortion still occurred when no human observed the feeds. The room did not respond to machine perception. It only responded to human awareness. This realization forced the team into uncomfortable philosophical territory. What exactly qualified as an observer? Was it consciousness? Intentionality? Subjective experience? No one had answers, but the room behaved as if it knew the difference. As the trials continued, a secondary pattern began to emerge. Not only did the room distort when unobserved, it distorted progressively more aggressively with each extended unobserved interval. The geometry did not reset fully between sessions. Although the room snapped back to normal alignment when a human entered, subtle statistical fingerprints remained in the data. The rate of distortion accelerated slightly over time. The maximum deviation thresholds increased by small but measurable increments. It was as if the room was learning, adapting, testing its limits. This discovery raised immediate concerns about long-term stability. The team debated whether to halt the experiment entirely, but curiosity won. Instead, additional safety protocols were introduced. Emergency re-entry procedures were established. Automated alarms were programmed to alert staff if distortions exceeded predefined thresholds. Physical fail-safes were installed to cut power and flood the chamber with light if certain sensor limits were breached, though no one could clearly articulate why light would help. It simply felt safer. One particularly revealing test occurred during a controlled 90-minute unobserved interval. The room was isolated completely. No live feeds were visible to any staff. All monitoring occurred via delayed recording buffers that would only be reviewed later. When the footage was analyzed, the distortion curve was unlike anything previously observed. The geometry began shifting within 3 minutes. By 20 minutes, corners folded inward beyond previous limits. By 40 minutes, depth layering collapsed into overlapping planes. By 70 minutes, large portions of the reconstruction became mathematically undefined. Certain frames showed spatial loops, lines that appeared to curve back into themselves while remaining straight. The room was no longer behaving like a distorted room. It was behaving like a broken idea of a room. When a human finally re-entered the chamber, the geometry corrected instantly once again. But the recovery was not perfectly clean. Micro-instabilities lingered for several seconds before fully stabilizing. Minor flickers appeared in the depth maps even after normalization. The room was taking longer to settle. That night, the lead systems engineer wrote a private note in the internal log. "We are no longer observing a passive anomaly. We are interacting with a system that responds to absence as actively as it responds to presence." The implication was clear. The room was not simply collapsing into randomness when unobserved. It was doing something structured, something intentional. No one said the word intelligence, but no one dismissed it either. The repeated tests had transformed uncertainty into pattern, pattern into behavior, and behavior into something dangerously close to agency. The experiment had crossed an invisible threshold. They were no longer just measuring space. They were watching something learn how to exist without being seen, and the room was getting better at it. The impossible angles. The data from the 90-minute unobserved interval did not behave like normal experimental results. It resisted interpretation. At first, the engineering team approached it the same way they had approached every previous anomaly, with measurement tools, reconstruction software, mathematical modeling, and error analysis. The assumption remained that if the distortion could be quantified precisely enough, it could be explained or at least categorized. That assumption did not survive long. When the raw point cloud data was loaded into the spatial reconstruction pipeline, the system immediately flagged multiple integrity violations. Surfaces intersected where no intersection should exist. Depth layers overlapped without transitional boundaries. Several coordinate clusters occupied mutually exclusive spatial positions simultaneously. The software attempted to resolve the contradictions automatically. It failed. Not by crashing, but by producing outputs that violated its own validation rules. Certain meshes generated negative volumes. Some vectors folded inward while maintaining linear continuity. Several frames produced non-manifold geometries that could not exist in any three-dimensional Euclidean space. The system labeled those frames simply as unsolvable. At first, the team suspected numerical instability. They reran the reconstruction using different algorithms, different precision levels, and different mathematical assumptions. Floating point tolerances were adjusted. Noise filters were disabled. Raw sensor data was processed directly without smoothing. The impossible geometry remained. It was not an artifact of computation. It was present in the measurements themselves. To understand what the data actually represented, visualization specialists created custom renderings that abandoned conventional perspective entirely. Instead of forcing the geometry into familiar three-dimensional projections, they allowed the data to display itself as layered topological relationships, distance fields, angular continuity maps, and curvature tensors rendered as abstract fields. The results were deeply unsettling. Certain regions of the room exhibited angular values that exceeded physically possible limits. In some areas, the internal angle between two surfaces measured greater than 180 degrees, a geometric impossibility for a closed structure. In other regions, angles fluctuated rapidly between contradictory values within the same frame. Corners appeared to exist in more than one orientation at once. Lines maintained straightness locally while bending globally. Distances shortened and lengthened depending on the direction of measurement. One physicist described it as geometry trying to escape its own rules. Another called it a space that no longer agrees with itself. The team attempted to isolate specific frames where the effect peaked. In one sequence, lasting less than half a second, the reconstruction showed a continuous corridor forming inside the room, a tunnel-like extension that folded back into the same physical volume without intersecting itself. The topology suggested more internal surface area than the room could physically contain. In another sequence, the depth map collapsed into a layered spiral where near and far surfaces exchanged priority repeatedly, creating a spatial paradox where inside and outside lost meaning. These were not visual hallucinations. They emerged consistently across independent sensors. Laser returns matched camera-derived depth maps. Infrared mapping confirmed spatial inconsistencies. Every system agreed on the impossible shape, even though none could fully describe it. When the team attempted to simulate these geometries inside advanced physics engines, the models destabilized instantly. Collision solvers failed. Constraint systems exploded numerically. The simulated structures either tore themselves apart or collapsed into undefined states. The shapes could not be stabilized even in virtual space. They were not just physically impossible. They were computationally incompatible with consistent reality models. As the team struggled to classify what they were seeing, philosophical language began to creep into technical discussions. What did it mean for a space to exist if it could not be consistently represented? Was the room actually changing shape, or was the concept of shape itself breaking down in the absence of observation? Some researchers referenced higher dimensional topology, suggesting that the room might be temporarily accessing degrees of freedom not normally visible in three-dimensional projection. Others speculated about perceptual stabilization, that human observation might be collapsing an otherwise unstable spatial field into a coherent configuration. No theory fully accounted for the data. The most troubling discovery came when the team analyzed angular continuity over time. The impossible angles were not random. They followed smooth trajectories. The geometry evolved coherently, as if the space were exploring a continuous family of configurations rather than glitching chaotically. The transitions showed intentional looking optimization, minimizing internal contradictions while still violating conventional spatial rules. The room was not collapsing, it was reorganizing, learning how to exist without being watched. During one extended unobserved run, the system captured a particularly disturbing sequence. As the distortion intensified, a new structural feature emerged near the center of the room, a region where angular measurements became undefined entirely. The reconstruction algorithms labeled it as a singularity zone, not because it behaved like a physical singularity, but because the mathematical descriptors failed to converge on any stable value. Within this region, distance lost coherence. Points inside the zone could not be reliably ordered in near-to-far relationships. Some metrics suggested infinite compression, others suggested discontinuous expansion. The zone appeared to drift slowly across the interior volume like a silent storm. When a human re-entered the room, the singularity vanished instantly. No trace remained in physical measurements. Only the data preserved its brief existence. Several team members reported an unexpected emotional reaction when reviewing the footage. Not fear exactly, discomfort. A subtle cognitive unease, similar to looking at optical illusions that refuse to resolve, or listening to sounds that almost form recognizable patterns but never quite do. The brain struggled to stabilize what the eyes were seeing. One visualization specialist admitted that prolonged exposure to the reconstructed frames caused headaches and mild vertigo. The geometry was not just difficult to understand, it was difficult to perceive. The human visual system was not designed to process spaces that violate consistency. This raised a new concern. If the room continued to evolve toward increasingly incompatible geometries, what would happen if someone entered it during one of these extreme distortion phases? Would the stabilizing effect still occur instantly? Or would the mismatch between human perception and unstable space create unpredictable consequences? No one wanted to find out experimentally. Safety protocols were tightened further. Maximum unobserved durations were capped. Emergency interruption procedures were refined. Automatic re-entry triggers were programmed if reconstruction instability exceeded safe computational limits, a proxy metric, not a true physical safety measure. Still, the data kept accumulating. Each new dataset expanded the library of impossible angles. Patterns emerged across sessions. Certain angular motifs repeated, spiraling distortions, folded corner inversions, mirrored depth inversions. The room seemed to favor specific families of spatial transformations, returning to them again and again with increasing precision, like a system refining its own behavior. The team began cataloging these motifs, assigning them internal identifiers like pattern sigma, loop variant C, inversion field 4. They were no longer just observing anomalies. They were building a taxonomy of non-Euclidean behaviors. One late-night analysis session produced a final, unsettling correlation. The rate at which new impossible angle patterns emerged was accelerating. The room was not merely drifting further from normal geometry. It was becoming more efficient at generating stable, impossible configurations. The stabilizing effect of human presence still worked, but the recovery phase showed increasing microinstability before settling. The room seemed reluctant to return to conventional structure, as if normal geometry was becoming less natural to it. The lead physicist summarized the situation quietly during a closed meeting. We are watching a space learn how to exist outside our rules, and our presence forces it back into compliance. Silence followed. No one disagreed. The room was no longer just reacting to absence. It was developing its own internal logic, a logic incompatible with human intuition, a logic expressed through angles that could not exist, spaces that could not be drawn, and structures that could not be simulated. The impossible angles were not errors. They were the room's true shape when no one was looking. And the more time it spent unobserved, the more confident it became in that shape. The final test. By the time the decision was made, no one believed the room was harmless anymore. The data from the impossible angles had pushed the experiment beyond curiosity and into something closer to containment. The chamber no longer behaved like a passive object under observation. It behaved like a system developing its own internal stability, one that actively resisted human presence. The question was no longer whether the phenomenon was real. The question was how far it could go. Some members of the team argued for immediate termination. The unpredictable geometry, the accelerating patterns, the lingering instabilities after re-entry, all pointed toward escalating risk. If the room continued evolving unchecked, there was no reliable way to predict the limits of its behavior. Others argued that this was the most valuable data the facility had ever generated. If the room truly represented a space that reorganized itself in the absence of observation, then interrupting the process prematurely might destroy a rare opportunity to understand something fundamentally new about reality. In the end, a compromise was reached. One final controlled test. Not to provoke the room further, but to measure its maximum unobserved behavior under strict containment protocols. The objective was simple in wording and terrifying in implication. Allow the room to remain completely unobserved for the longest duration ever attempted. No live feeds, no human monitoring, no real-time intervention unless predefined safety thresholds were crossed. All recording would occur passively and be reviewed afterward. The chamber was sealed. Automated systems confirmed isolation integrity. Environmental controls stabilized. Redundant power systems engaged. Emergency access locks were armed but disabled unless manually overridden. The countdown began. The first 10 minutes showed familiar early-stage distortion patterns, minor angular drift, subtle depth expansion, nothing outside previously observed ranges. At 20 minutes, the geometry entered accelerated deviation. Corners folded inward more sharply. Spatial gradients intensified. Reconstruction instability increased. At 40 minutes, the room exceeded all prior distortion benchmarks. Impossible angles multiplied across the interior volume. Several singularity zones appeared simultaneously, drifting and merging unpredictably. Depth layering collapsed into chaotic topologies that resisted consistent mapping. The automated monitoring system flagged multiple threshold violations, but remained within authorized tolerances. The test continued. At 60 minutes, something unprecedented occurred. The distortion patterns began to synchronize. Previously independent anomalies aligned into coherent global structures. Angular fields stabilized into repeating wave-like formations. The room's geometry no longer appeared fragmented, it appeared organized. The space was forming a new equilibrium state, one that did not resemble a room at all. The reconstruction model struggled to render the transformation meaningfully. Abstract visualizations showed nested spatial loops, recursive surface folding, and dimensional overlaps that suggested internal volumes exceeding the chamber's physical limits by orders of magnitude. The room was becoming larger on the inside, not in measurable distance, but in topological complexity. At 78 minutes, the system registered a sudden spike in reconstruction entropy, a signal that the internal geometry had crossed a critical stability threshold. Predictive models failed to converge. Several algorithms entered protective shutdown states to avoid cascading computational errors. The automated alarms escalated to critical. According to protocol, this was the point where human intervention was authorized. But no one moved immediately. The control room was silent except for the quiet hum of servers and the rhythmic pulse of warning indicators. Engineers stared at abstract renderings that no longer resembled any recognizable space. If the room continued evolving, no one could guarantee that re-entry would stabilize it safely. But if they waited too long, stabilization might become impossible. Finally, the lead safety officer issued the command. Re-entry initiated. The access corridor lights powered up. A single technician approached the chamber door, equipped with emergency sensors and tether protocols. The door unlocked with a muted mechanical release. As the door opened, the chamber was flooded with light and human presence for the first time in over 80 minutes. The effect was immediate and violent. The reconstruction systems recorded a massive geometric collapse as the unstable topology attempted to reconfigure into conventional space. Angular fields snapped back toward Euclidean constraints. Singularities dissolved abruptly. Depth layers flattened into coherent surfaces. For several seconds, the system registered extreme instability spikes, higher than any previously observed during re-entry. Then, suddenly, stability. The room returned to its original dimensions. The walls were straight, the corners were 90 degrees, the floor was level. The technician reported no unusual physical sensations, no visible distortions, no auditory anomalies. From a human perspective, nothing had happened. But the data told a different story. Post-test analysis revealed residual micro-instabilities lingering in the geometry for nearly 30 seconds after stabilization. Subtle fluctuations rippled through the spatial metrics before finally settling. The room had resisted normalization longer than ever before. More concerning, the internal models suggested that if the unobserved interval had extended even a few minutes longer, the stabilization event might have exceeded safe computational predictability thresholds. In simple terms, they might not have been able to bring the room back. That conclusion ended the debate. The experiment was terminated permanently. All future unobserved tests were canceled. The chamber was placed under continuous human access protocols. At no point would the room be allowed to remain unobserved for extended durations again. The final report avoided dramatic language. It described nonlinear spatial instability correlated with absence of direct human observation. It recommended indefinite suspension of further trials. But among the team, the truth was understood more plainly. They had come dangerously close to allowing a space to evolve beyond their ability to anchor it back into reality. The room had shown them what it wanted to become when no one was watching, and it had not wanted to remain a room. The unanswered question. The room still exists. It was not dismantled. It was not destroyed. It was not sealed behind layers of concrete and forgotten forever. It remains where it was built. Silent, empty, perfectly ordinary in appearance. 4 walls, a ceiling, a floor. Nothing about it suggests that it once twisted itself into shapes that could not exist or briefly abandoned the rules that define space itself. If you were allowed to stand inside it today, you would see nothing unusual. The corners would meet cleanly. The shadows would fall where you expect them to fall. The air would feel no different from any other enclosed room. Reality would behave. That is the most unsettling part. Because the room did not change when people were present. It changed when they were absent. After the final test, the facility implemented permanent observation protocols. The chamber is never left unattended for extended periods. If personnel must exit, another observer replaces them immediately. Live feeds remain actively monitored by human staff. Automated systems alone are no longer considered sufficient, not because the room is dangerous in a conventional sense, but because no one wants to find out what it becomes when nothing is watching it. The official reports describe the phenomenon cautiously. They avoid speculation. They emphasize uncertainty, measurement limits, and the need for further study under safer conditions. But privately, many of the researchers were left with questions that no data set could answer. If a room requires observation to remain stable, what does that imply about the nature of space itself? We are taught that reality exists independently of perception, that mountains remain mountains whether anyone looks at them or not, that empty rooms stay exactly as they are when the lights go out and the doors close. The room challenged that assumption. It suggested that observation may not merely reveal reality, it may participate in holding it together. This idea is not entirely foreign to science. At the smallest scales, quantum systems behave differently when measured. Probabilities collapse into outcomes. Possibilities become facts. But those effects are confined to particles, not walls and corners and distances measured in meters. The room operated on a scale where observer effects should not exist, and yet they did. Some researchers wondered whether human consciousness itself was acting as a stabilizing field, not through any known force, but through some deeper relationship between awareness and structure. Others suggested that the room might represent an emergent phenomenon. It's where complex systems under extreme isolation can drift into unstable configurations unless anchored by external reference frames. None of the theories were satisfying. All of them felt like approximations orbiting a deeper truth that remained just out of reach. What troubled many of the team most was not the room's behavior during absence, but its apparent learning. The distortions became more organized over time. The impossible geometries refined themselves. The system adapted to repeated stabilization, recovering more slowly with each cycle. The room did not behave like random noise. It behaved like a system exploring its own potential states. As if, given enough time unobserved, it might eventually reach a configuration that no amount of human presence could fully undo. That possibility remains untested, and intentionally so. But the implications extend far beyond a single chamber inside a research facility. If observation stabilizes reality locally, what happens in places no one ever observes? Deep ocean trenches, abandoned underground structures, unmonitored regions of space between stars. We assume emptiness is simply absence. But what if emptiness is freedom? Freedom from the constraints imposed by perception, measurement, and expectation. Freedom for reality to reorganize itself in ways that human minds are not equipped to recognize or survive. The room forces an uncomfortable question. Are we witnessing reality, or are we participating in maintaining it? Every time you look at a wall, a street, a sky, you assume those things would exist exactly the same if you were not there. But what if your awareness plays a subtle role in keeping those structures coherent? Not through mysticism, not through intention, but through some fundamental coupling between observation and stability that we have not yet learned how to measure. Perhaps the universe tolerates ambiguity when no one is paying attention. Perhaps structure itself is a negotiated agreement between matter and mind. The room may have simply exposed a small crack in that agreement, a place where the rules loosened when the witness stepped away. There is another possibility that unsettles even the most skeptical thinkers. What if the room was not just destabilizing? What if it was expressing a more natural state of space? Perhaps the geometry we experience, straight lines, fixed angles, stable dimensions, is not the default configuration of reality. Perhaps it is the version that emerges under continuous observation, measurement, and interaction. Remove the observers long enough, and space may relax into something more fluid, more complex, less constrained by the limitations of human cognition. The impossible angles may not have been errors. They may have been what space looks like when no one is asking it to make sense. If that is true, then the room was not becoming broken. It was becoming honest. That thought carries an unsettling implication. If human presence enforces order locally, then what happens when observation disappears entirely? Not just from a room, but from a planet, a system, a civilization. Does reality slowly drift into unfamiliar configurations when no minds remain to anchor it? Or does something else take the role of observer when we are gone? The room offers no answers. It only leaves us with silence, data, and unease. Even now, somewhere inside that secured facility, a quiet room waits, waiting to be observed, waiting to remain stable, waiting to behave like a room. Because if observation truly keeps it still, then the most dangerous moment is not when something is watched. It is when nothing is watching at all, and we may never truly know what reality becomes in that darkness.
Shadows